Now I want to apply some of what we've talked about in chapter 3 and kind of look at molecules in a different way with what's called percent composition. So the idea of percent composition is we want a breakdown of atomic contributions to mass. So when we think about a molecular formula, for example, C9H8O4, that is a counting representation of atoms in molecules. We know that is the most useful, the most representative. That is how we talk about molecules. That's how we think about molecules. But we can also describe molecules based on the mass contributions of those types of atoms. So for example, aspirin here, C9H8O4, there are 8 hydrogens in this molecule, and there's 8 of them, but so there's a lot, but hydrogen atoms are really, really small, so they don't really contribute much to the mass of this molecule, and therefore the mass of the compound. So in, say, 10 grams of aspirin, there's not a lot of mass of hydrogen in there. And so a percent composition just gives us a different way to represent that sort of what is the distribution of atom types and kind of the representations of the different matter in that compound. So when we compute them, we'll walk through an example, so don't worry too much, but when we're computing these, what we're really looking at is the idea of you basically take the mass of those atoms using the molar mass basically of those atoms. So you can see, for example, carbon, there's 9 times the 12.01. That reflects the 9 times carbon's molar mass in the compound divided by the molar mass of the entire compound. And then you're just taking it as a percentage, right? So they all add up to the overall molar mass. And you can see then that you get these percentages. One thing to note, the percentages of all the different types of atoms should add up to 100. So first off, you can define percent composition for every atom in every molecule, and collectively they add up to 100% because all the mass has to go somewhere. And as expected, there are 8 hydrogen atoms, but they're less than 5% of the total mass because they're very small. Oxygen, at only 4 oxygen atoms, they're the biggest atoms in this molecule, so it's over a third of the mass. So it's just kind of a different representation that we can see of describing the distribution of matter in a compound. So let's work through an example of how we kind of calculate molar mass just to get some context for it. So calculate the percent composition of calcium nitrate. I got my equation or formula there, CaNO3 2. So just like everything else, we can always start with asking what do we want? In this case, it is percent composition. What do we have? A molecular formula. So percent composition is always a description of a compound, and we need the formula of that compound. So percent composition, there's no conversions here. There's no any sort of, kind of like critical thinking here. It's just going to be a matter of we have an algorithm for calculating that. We want to recognize that percent composition always has an algorithm, and we can use that algorithm. We take atomic molar masses as a percentage of the compound's molar mass.
So when we want percent composition, we want to recognize that that is just overall a process for the entire compound. The first step is going to be determine the molar mass. So we want to know the molar mass for the entire compound. We want to look at what we have. So I can see I have the 1 calcium. That 2 out there that's outside the nitrate, we know that 2 applies to both those things that we have right there. So that means I have 2 nitrogens and 6 oxygens. So I can look that up. 40.08 grams per mole for calcium, 2 times the 14.01 grams per mole for nitrogen, plus the 6 times 16.00 grams per mole for oxygen, giving me a total of 164.10 grams per mole for the entire compound. So that is the molar mass for my entire compound. So the idea of percent composition is basically what is the contribution of my different atom types to this overall mass. So what I'm going to do is I'm going to take each type, calcium, nitrogen, and oxygen. And so how I'm going to calculate this calcium is 1 times the 40.08 grams per mole divided by the total 164.10 grams per mole times 100. And that is going to be equal to 24.4%. And so when we're looking at this, what we can see is that calcium was, we just basically take the 40.04 part of the molar mass and we put that right there for the calcium component, because that was how much of calcium was contributing to the overall molar mass. We basically just isolate that and divide that by the total. That's our percentage. So then for nitrogen, it's going to be the 2 times 14.01 grams per mole divided by 164.10 grams per mole, again, multiplied by 100, and that's going to be equal to 17.1%. You can see that we have 14.01, 2 times 14.01, and then for the oxygen, it is 6 times 16.00 grams per mole divided by 164.10 grams per mole times 100, giving me a total of 58.5%. And so one thing to note, 1, 2, 3, each atom type in a compound has a percent composition. They all add up to, I think this actually, I think in this case you get 99.9, yeah, because of rounding, which is fine, still close to 100, it's just a rounding issue. If you went to one more sig fig, you could get to 100% likely. And so it just gives us a different representation. You know, we know that, for example, oxygen, over half the mass of this compound is oxygen. There's a lot of this is basically oxygen. So even though when we see it, you know, it's just kind of in the nitrate here, really most of the mass that we're dealing with is oxygen. So most of what's in there is oxygen. You know, and calcium, even though we only have one of them, because it is quite a heavy atom relative to the nitrogen and oxygen, a fourth of the mass is calcium. And there's only one of those, it's a big atom, and it brings a lot to the table, contributes a lot. So we can always calculate percent composition. It's just a matter of calculating the overall molar mass and calculating the contribution of each atom to that.
So why do we care about percent composition? Well, what it really lets you relate is the mass of element to mass of compound. So for example, what mass of calcium is contained in 34.6 grams of calcium nitrate? So we just computed the percent composition. We know that the mass percent of calcium inside there is 24.4%. So what we can do is we can take that 24.4%, or we can use that as a ratio of 0.244. And so if we take that and multiply it by the mass of calcium nitrate, so we can see it, the 34.6 comes from right there. Multiply that out and we get 8.44. So that gives us the mass of calcium. So if you're in an application where you are consistently, say, taking some sort of compound and refining element out of it. So for example, you're digging calcium nitrate out of the ground and you're refining it into calcium and you want to know what mass of calcium is coming out. This lets you do that calculation consistently because, you know, it's a decent amount of work to calculate percent composition, right? There's a bit of legwork to it, but once you do it, you can use that number over and over again. So if you're ever looking at this compound, if you're working a lot with this compound, it's always 0.244 times the mass of the compound to get the mass of calcium. And so, you know, that lets you be useful, or if you say you're doing a reaction where you'd want to know how much calcium's in there or something like that. This is one of the utilities. We'll see in another video, there's another utility to percent composition, but kind of this is one of its functions and how we can use it. All right, first video down of the set. We're looking for questions on participation 6-9 due Tuesday, the 9th. Depending on when you're watching this on Tuesday, we also have the identifying an unknown substance lab, pre-lab technique comprehension and notebook. All are going to be due at the start of lab, which is 9 a.m. On Tuesday. And then Wednesday, we'll have module 3 homework over and active and the post-lab due. On Thursday, at the start of the lab time, we will do our exam 1 in the classroom, room 141 that we've used before. And so we'll do this at the start, it'll be 9 a.m. to 11, we'll have 2 hours of test, and then we'll go to the lab room and do reactions of copper.
So we'll pop over into reactions of copper. After that, we'll do that. So we're still going to do a lab. We'll start it at 11. The assignments are still due at 9 a.m. before it starts. And then we'll have lectures, Thursday, Friday lectures still at the end of the week. If you have any questions about anything, let me know. There is the review in the exam 1 folder. You can take a look. Get 3 points on your test. And if you want to like do it, meet and ask questions, we have office hours on Tuesday after class. There's also, we can meet for WebEx like virtually or anything like that. Email questions, whatever you got. Otherwise, we still got to watch these videos. This material will be on the test. So we got to finish chapter 3. I'll see you in the videos. Bye.